Hello, everyone. Welcome to the last session for the day. Today we have INCF and admins from INCF to talk about the organization right now. So, would you like to introduce yourselves?
Hi, I am Malin, Community Manager with INCF.
Hi, I'm Arnab. I work as a product manager at Credit Suisse, and I have been involved with INCF for almost 4 years now, three and a half years actually. So I was a GSoC student at INCF back in 2018, and then 2019 I was a mentor, and I was fortunate enough to attend the GSoC Mentor Summit at Germany along with Malin. And last year onwards, I've been trying to help Malin with some of the org admin stuff. So I am a co-org admin this time.
That's awesome. I think it's been with GSoC since about 2011. It's
Yes.
a lot of years. Awesome. So we can move on to the presentation and we can side by side talk about what the organization is, what kind of projects you have.
Okay,
Sure.
let's get started. So this is what I'm planning to talk about as it started. I'll give an introduction to us, to the organization, our tech stack, which is very varied. I will link to some demos. Will you be able to share these slides afterwards so people can visit the links themselves, maybe? And there's a guide for beginners and a link to some resources. And then I hope you have lots of questions. So this is us. That's me at the left, and that's Arnab in the middle, and it's Arnab's cool project on the right. And I have the background in computational neuroscience. That's why I'm with INCF, because INCF works with neuroscientists. And INCF does a lot of things that are not immediately relevant to GSoC, but one of our core things is training. And we want to enable every student who wants to train, and we work on open training materials and collecting community materials and making them available to students. We also work openly as an open science organization. We've done that from the start. And we work to align international efforts in brain science to make sure that people work together instead of in parallel, and that what they do is compatible and reusable by others.
Mm-hmm.
So what we do practically is that we support community standards and best practices, and that can be file formats, it can be ways to organize your data and so on, so that you can build tools that work for everybody with everybody's data. And we develop and provide training and education. We serve as an interface between big international large-scale brain projects, Brain Minds, Human Brain Project, the Japanese brain projects. And we have a formal and informal partnerships with international stakeholders to make sure that neuroinformatics, and that is information science in neuroscience, is on the agenda. And for the last 10 years, a lot of science has been focused on FAIR, which is findable, accessible, interoperable, and reusable. And we are officially a FAIR organization in neuroscience. And standards help a lot with being fair. So who are we for? We provide a forum where neuroinformaticians can develop their skills, but researchers can train and data science and data skills. We provide a forum for infrastructure providers and tool developers to work together, and we work towards funders to make sure that neuroscience tool and such efforts are funded. So our community is mainly neuroimagers, neurophysiologists, brain atlas builders, and computational modelers that make brain simulations. And we have a lot of neuroscience tool builders, and many do this as part of their research. So they develop the tools they use in their own research, and some of them also develop tools that are used by a lot of other researchers. And these are very important to us as an organizations because they build the tools that use the standards and best practices and make them available to the rest of the community. And that most of our community are also fans of open science and reproducibility and such things. And our tech stack, and Arnab can help me here because he has as much knowledge of our projects as I have. I would say that Python is common and growing still. C++ is common because we have a bunch of old tools that have been around for 10 years when C++ was the big thing to do. JavaScript is fairly common. Deep learning and machine learning is becoming more popular. We've had such projects for about 3 or 4 years. And user interfaces and other usability aspects of tools are common because that's the thing you need, but you might not do immediately if you have limited resources. A lot of our community likes Jupyter notebooks, and there is also some databasing and needing to deal with data aspects. So there's a lot of markup and databasing. And Arnab, what would you add to this list?
Yeah, so I mean, you pretty much covered most of it, and I think I agree, especially about the first 3 points, that I think Python, JavaScript, and C++ in that order are probably the three most common languages that we have for most of our project ideas. And also, I think, yeah, I mean, I would essentially repeat what Malin said, that in the recent years, we have been observing that quite a few of our mentors who belong to different sub organizations are coming up with project ideas that have some flavor of deep learning or machine learning. I mean, not the entire toolkit as such, but some flavor or some aspect of it, maybe building a CNN or tweaking some of the layers of a CNN, and then with a pinch of a neuroscience related data to sort of analyze and come up with an analytics framework. Or also another common kind of project that we have is something front end in JavaScript, like probably building the interface for an existing analytics framework. And yeah, I mean, I would probably add more to this when we come to a next slide of how beginners can contribute to INCF.
Mhm. Thank you.
Yeah.
And so I have 4 demos for you that I think we can save to the last, so we know that there is time. But otherwise, I'm hoping that these slides will be shared and available to everybody, so you can use these links. All go to our portal Training Space, which has lots of video lessons in everything, and especially in neuroscience tools and methods. And how beginners can get started, we have moved all our GSoC engagement to our forum Neurostars because it makes it much easier to track and help if conversations get stuck and somebody forgets to reply or something such. So you register an account on Neurostars. It's free and it's easy. And it's important you choose a good username, not a cool coder name, but your real name or parts of your real name or initials or something that is recognizable. Also, a photo or other recognizable avatar, it doesn't have to be your face, but something that nobody else uses. And each project has a post on this forum with GSoC 2021 in the title. So you should be able to find all the projects on there. Otherwise, you can go back to the list and look for keywords and titles and so on and use that to search. And if you post, we ask you to reply to project posts as a first measure at least, and you tag mentors in your in the post. They should be tagged already in the original post so you can see their usernames. If not, you can tag me or Arnab, and if you don't get a reply in like 2 days, you ping me or Arnab and we help prompt the mentors to reply. And you will need to ask mentors because it varies between projects. You will need to ask them what they need from you to continue, if they want you to do some small task, or if they want you to answer some questions, or if they want you to tell them more about something. And do you have other ideas, Arnab, something to add to this?
Yeah, so I mean, one common trait that we've sort of observed in prospective GSockers is that uh, there are a couple of things actually that I would like to add. So we've observed that often, when students come up into the Neurostars portal for the first time, they might initially feel a bit overwhelmed because there are so many project ideas. So from that perspective, I would say that maybe you can look at the project ideas from two different angles. And if you think that you come across a project idea wherein you have a match across both these criteria, then feel free to get in touch with the mentors and read the project idea in more detail and ask questions. So those two criterias that I like to talk about is the tech stack compatibility and the idea compatibility. So when you come across the 50 plus ideas, there might be certain project ideas that really excite you, that you think you will be able to contribute to, and that you think will have a very big positive impact in the neuroinformatics community, larger community. So try to shortlist project ideas on that, and then also sort of look at whether you are compatible with the tech stack that is being suggested. I mean, fair enough. There are quite a few project ideas where the tech stack is not fixed as such, but most of the project ideas will already have a line wherein the mentors might have mentioned what tech stack they are expecting the project to be in. I mean, of course, if it's something like, let's say, a front end project, then more often than not, it is going to be a JavaScript based project. The flavor might differ depending on whether it is React JS or Node.js or whatever. But if you think that a JavaScript project is what you want to do, then you might want to shortlist ideas based on that, and also apply the other criteria as to which project ideas are exciting you. So that is the first point about choosing a project idea. And the second thing is, do not be afraid to ask questions or queries. I mean, the mentors are there on Neurostars portal to help you out, and also Malin and me, we are also there to help you out in case you have queries about the project idea or other GSoC related admin queries like dates and times and all of that. We are there to help. So do not feel that if I ask a question, will the mentors not reply? Just ask whatever queries you have to. That is the second thing. And the third and final thing would be that try to ask most of the queries, especially if the queries are related to the project. If it's not something personal about you, if it's about the project idea, then feel free to ask it publicly on the project idea, because often we have students who reach out to us separately asking the same question. So if you publicly ask that question, then don't think that you are going to lose out on the project proposal because other students will also find out the answer. Don't think about it in that way, because open source is all about collaborating and taking the mission forward instead of just focusing on yourself as an individual. So it's important that you ask whatever queries you have, and do not feel afraid to ask questions. We are there to help you. And the last point to add, sorry, Malin, I talk a lot. I have this bad habit, but yes, the last point would be that INCF being a neuroscience related organization, almost all the projects will have some flavor of neuroscience to it. So do not feel that it is going to be very tough to gain that knowledge, because at the end of the day it is GSoC. So at the end of the day it is a coding project. It won't be a neuroscience project. But yeah, the data that you are working with might have its origin in neuroscience, or might be related to digital biology or neuroinformatics. So from that perspective, whatever neuroscience related knowledge you need to have for the project, your mentors will definitely help you. So there might be some projects in which there might be some research papers that you might have to read, or some specific subdomain of neuroscience that you might have to read up a little bit about. But don't be afraid that it's a new domain, so how will I understand? Mentors are there to help you always. So with that in mind, I would now hand it back to Malin and Sakshi.
Wonderful. Thank you. I should also
Thank
add,
you.
if mentors sometimes don't reply, it's usually because they are very busy people who get hundreds of emails per day. And we try to help you ping them. So don't be afraid to ask us for help if the mentor doesn't reply. It's usually not intentional. And here, to end this talk, is our list of resources. I really recommend the Google pages for GSoC. They have excellent student guides, mentor guides, timelines, and FAQs. And you are also welcome to use our forum to ask any neuro questions you have. There is a neuro questions category where newbie questions are welcome. And there is a lot of training material on our training space. You can learn a bit about different neuroscience branches and subfields. You can learn a lot about tools, and it's very useful. It also has some data science, basic data science. And if you don't find what you need from ours, I would also recommend the carpentries, for instance. And many of the projects have tutorials and intros and other things in their GitHub repositories. Will you add something, Arnhem?
No, no, Malan. I think you pretty much covered it.
Okay. And then, for last, I want to tell you that if you want to learn a bit more about INCF, we have our yearly meeting fairly soon in mid-April. That's the INCF Assembly. And it will be about everything neuroscience, findable, accessible, interoperable, reusable, and different subfields in neuroscience. There's a 2-week program that you can find on our website, and it might not you might not be an overall big neuroscientist, but there's definitely something that you will find interesting. There's a bit of data science and a bit of training also, and it's discounted for members. And INCF membership is also not expensive. It's $20 for a student membership, for instance, and you get access to INCF as a community. You get to participate in stuff. You get to have your opinion on stuff and help us form strategy and activities. But you also get some protocols with IO and some other benefits, and all the FENS, Federation of European Neurosciences membership benefits. And for students specifically, what INCF provides is a way to meet people you wouldn't meet otherwise, like major stakeholders in global neuroinformatics, professors from all over the world who are experts in their fields. And you have us to help showcase your efforts. If you do something cool or something that's relevant to the community, we will help you promote it to the community. And you will have access to our experts who are plentiful and usually good at giving advice and recommendations. And also, we have a lot of training, partly on the training training space portal, but also in our community, we have lots of people interested in training. So we know all about different courses, and we are interacting with all the other big neuro course holders. And that is the end of my presentation.
Thank you so much for the lovely presentation. Even you, Arnav, I think you covered some great points, especially the one where you said, "Don't be afraid to post your question, thinking others might copy your project idea or they'll get the
Hmm.
proposal." I think that was a very, very important point.
Yes.
And yeah, in the end, it's more about contribution.
Yes.
So I think we started getting a few questions. If you're ready, we can move on to that.
Yes.
Yes.
So one of the questions is, I know Python on a basic level. So is there like a language fluency requirement that you have?
It depends. It varies a lot between projects. For some projects, you just need basic Python, and for some projects, other projects, you need more advanced Python skills. It usually says so in in the project description. If it doesn't, you are free to ask mentors. I know this much. What do I need to learn more? Is it reasonable for me to be able to learn it
Mhm.
during or before the project starts? So I mean, you should come into this with a I want to learn perspective. So don't only ask how much you know to be able to take on the project. It's also what you can learn from the project and what you can learn before the project to actually be able to succeed.
Thank you. Another question is the program free?
Yes, it is free, and if you are accepted, you get a stipend.
Mhm.
So
I think a follow up to that would be, can they contribute outside of GSoC, and that would that be free as well?
um, if you find a mentor that you want to work with and it's not within GSoC, I mean, it's totally free. They will value your effort, and they will hopefully give you some good
Right.
experience exchange.
Thank you. Uh, I'll
So
wait for a few more questions.
besides,
You can start sending your questions in the comments. And okay, I'm posting the link to the presentation in the comments. Till then, Arnab, can you share a bit about your personal experience applying and then turning into a mentor? Is there something you would like to cover about the experience?
Yeah, so I mean, it's been a pretty rewarding experience, like intellectually rewarding, and also like Malin mentioned, there was also a stipend that I received, so it was
Mhm,
also rewarding in that way. But I think the important thing to note about GSOC applying to any organization, and it's no different for INCF as well, is that
mhm,
initially most students that are trying to crack GSOC would start contributing to a certain organization's code base, or start reaching out to
mhm,
mentors and start asking questions about how they feel the project should be implemented.
mhm,
However, I have noticed both, when I was a prospective student, when I was applying for GSOC, as well as a mentor and org admin, I've noticed that typically after few days of time, a lot of students then sort of give up, because
mhm.
uh, what happens, and this is true for open source in
Right.
general, that whenever you are trying to contribute to a new code base that you are
Mhm,
looking at for the first time, it feels a bit uncomfortable, because there are so many things that you don't know, like about the organization, about the code base, and also the
mhm,
language that you're contributing it. Often you might feel that there's a certain language that you are fluent with, because of projects that you've probably done in high school or university, and
mhm.
then when you come into open source and you're like, okay, so maybe I didn't know as much as I thought I knew. uh,
Right.
but I think it's important to note that 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 uncomfortable feeling which is there, it's actually a good thing. It's because you're learning something new, and so that initial phase of like first couple of months when you're trying to get into open source is very critical, because that initial couple of months is when most of the students, they actually stop putting in effort. So I think
Mhm,
grit plays a very important role, especially
right.
first couple of months. And again, like, different students who apply to GSOC have different expertise levels. Some of them have been avid coders for a long time, but some of them are probably getting into coding,
Mhm,
like just getting into coding as a new thing. So maybe they are being introduced to things like version control system and Git and GitHub and all of that for the first time. So the
right.
only tip would be that don't give up. Like, have a little bit
Mhm,
of grit and push through that first couple of months of effort. Because as Malin also mentioned, mentors are always there to help. So even if it might happen that 1 or 2 days later a mentor is replying, but mentors are there to help. So that is one point. And the second thing is that see, you have to understand that Google Summer of Code as a program, the aim of Google
mhm.
Summer of Code is to get more students interested into open source software.
Right.
And as part of that, you have to be the one driving the conversation about the project proposal. There is a
Right.
reason why the project ideas are just 50 word or 100 word long. It is
Mhm,
because the project idea is just going to give you a brief idea of what the problem statement is. So the project idea is just a problem statement, that this is the problem, and this is
right.
the problem that we need some student to solve. But how
Mhm,
to implement that is something that you have to decide. So it might also be that if you think that maybe the tech stack that is mentioned, maybe the language that is mentioned, if you think that there is another programming language in which it can be better implemented, feel free to tell the mentor. So at
mhm,
the end of the day, you have to take ownership of the project idea and propose what you want to do, and that is why it is called a project proposal essentially. So that is why it's just a 50 word idea that you have to ask yourself, if I have to solve this problem, how do I solve this in a step by step way. So
mhm,
so the goal of a project proposal is to have a very detailed step by step procedure about how you are going to achieve the outcome, the solution. So you have to
right.
think in so much detail that you have to understand, try to understand on a weekly basis what contribution you will do. So you can come up
Mhm,
with a plan that week 1 this is what I will do, week 2 this is what I will do, week 3 this is what I will do, so on and so forth for the entire period. Now of course it goes without saying that when you're making this kind of a detailed project proposal on a week by week
mhm,
basis, things change. Some weeks you might be before schedule, some weeks you might be after
right.
schedule, and that is completely understandable. But all of that, your mentors will also tell you that when you're preparing the project proposal, if your mentors feel that maybe you are over promising too much, that in 1 week I will I will complete the project. So then your mentors will also tell you this is not possible, this is not humanly possible to like complete everything in 1 week or 2 weeks. So I would say don't over promise and under deliver, but instead of that, just be sort of like true to yourself, and try to understand that how you will achieve it. And really, I mean, GSOC is the primary goal of GSOC, and I'm sure Malin would agree, and the GSOC admin team, like the Google team from open source office team that they have, they've also said this many times, even in the mentor summit, that the end goal of GSOC is to give a rewarding and intellectually enriching experience for the students. We
Right.
want the students to have a great experience, that you are learning new things, you are contributing to things that are actually going to be used by people. And the project ideas that INCF has, that has long lasting impact in the world of neuroscience. So essentially, it might not be the same as winning a Nobel Prize, but essentially you
Mhm.
can pat yourself on the back if you're contributing to INCF, because you are having a direct impact on the future of neuroscience and how brain cell
Right.
research and neuroinformatics works. So from that perspective, of course, it goes without saying that as a young student you might not always know everything, and that is fine, because the moment you feel uncomfortable, that you are surrounded in a code base that you're looking at for the first time,
Right.
maybe some new nuances about a certain language that you've been using for a long time, this language, but maybe it's for the first time you're learning something new, that's a good thing, right? I mean, you're learning something new, and at the end of the day, mentors are always there to help. And the
Mhm.
I'm sorry, I talk a lot, but
Mhm. No
and the
problem. It's
and
very
the
insightful.
and the last thing is that the last thing is that in the open source community and the world of open source software in general, the one thing that is most exciting to see when org admins or mentors look at the students is that if someone takes
Mhm.
initiative is the uh, like favorably looked upon thing, because what happens is, suppose there is a project idea, and in the project idea some details are given that maybe I'll give a simple example, that maybe there is a neuroscience related project idea, that there is a research paper of maybe some neuroscientists who maybe are faculty members at MIT or McGill University, and they have a
Mhm.
research paper, and what they are proposing is for someone to come up with a coding implementation of the paper, right? So
Mhm.
straightforward, that you have to read the paper, understand it, and then implement it in maybe Python or JavaScript or something. So if these resources are given in the project idea, that if the mentor has already shared the link, that this is the research paper, and this is what I want someone to help me with, to have a coding like a coded version of the same. So
Right.
so if you want to solve this problem, don't try not to comment something like hello, I am I am Arnab Banerjee, I am from so and so university, and I want to do GSOC with you. So that is fine, but go one step ahead and actually read the research paper, and then after you read the research paper, it is completely understandable if you don't understand anything, that's fine. Then you can ask that, you can ask the mentors that I read this research paper, and I have so many questions, it seems a little challenging, can we please set up a video call and have a discussion about this research paper. Your mentors would be more than happy, because they will notice that you've taken the initiative to open the link and read the paper. But if you just say I want to do GSOC, even the mentors won't know how to help you, because the
Right.
mentors won't understand what is it that you have a difficulty with. So read the project idea and ask yourself a simple question: if I were to implement this project, how would I implement it? And come up with some steps, share it with the mentors, and most important thing is getting feedback from mentors. So do not be afraid to ask questions, but also do not be afraid to take initiative and do something about it instead of just asking. Sorry if that was a very long answer, but yeah, that's it from my side.
I think your last point actually reminds me that they need to show interest in the organization and the project itself rather than GSOC as a whole.
Yeah, and I mean, I think what Sakshi had asked initially was about the GSOC experience in general. So that was, I guess, what I just said was more along the lines of my experience as a student, how fulfilling it was, because I was constantly, learning new things. And my mentors,
Right.
most of the mentors are senior people who have been in academia or research for a long time. So the kind of things that you learn when you interact with them on a daily basis throughout the summer, it's phenomenal. And even post GSoC, no matter which direction you are trying to take, you
Mm-hmm.
might be trying to get into software engineering, or you might be trying to go into academia, and or maybe you might be an aspiring PhD student, or you might be an
Right.
aspiring professor, or you might be an aspiring software engineer. No matter which direction you take, whether it's the corporate world or academia or research, the one thing is that if when you become a GSocer, and when you get that tag of becoming a GSocer, that you are an ex GSocer, then
Mm-hmm.
the network that you get access to, I mean, the kind of people that you meet, it's nice, because later on, when you have, let's say, the mentors and admins who are there not only in INCF, but in
Mm-hmm.
general across the larger GSoC alums who are there, the alumni of GSoC, basically mentors and admins, they are all pretty much doing well wherever they are, be it academia or research or the corporate world.
Right.
So you basically get access to an unparalleled network of software engineers and professors and researchers who are at the top of their game, in a way, in
Mm-hmm.
whatever domain they are in. So that is one thing that I definitely think had a positive impact for me when I was fortunate enough to go for the Mentor Summit in Munich. And also, we've noticed that most of the GSockers, wouldn't say most, but at least, Malin, correct me if I'm wrong, but I think around 50% of the GSoC students end up staying back and contributing to the organization in the future, right? In either as a mentor or an admin,
Mm-hmm.
because it's a very rewarding experience. I mean, you learn new things, and it's about being curious about how things work. And yeah.
Yeah, we
And
actually have
yeah.
about 7 or 8 different projects that have been with us for most of the whole GSOC run from 2010 something. And they typically keep their students along. And when they are not students anymore, they might be mentors or at least the developers and maintainers of the code base.
Mm-hmm. Thank you. So I think we also got a follow-up question to something you just said. Um,
So I see you
Hmm.
put a line in the comments. That's good. That's gonna answer some questions. So I would say that read the timeline carefully and be aware of the deadlines. And also be aware that you will not be able to get last minute replies from mentors. So anything you do, you need to have a buffer of time for them to reply. So
how do you get?
yes, research papers. Um, the first step is to be able to find the papers that if they are open to read. Most of the papers are open science in our field nowadays, but they used not to be. If you can get it openly, do I would just say start reading it. Read the introduction. Read the discussion at the end. Then maybe read through the methods and so on later. That's how many people read the science papers. You don't read them from start to end, but you look at the beginning and the end, and then you sort of extrapolate how to deal with the middle. And I would also say it's fine to post questions on Neurostars. If you come to the Neuro questions thread and say, I read this paper and I wonder these things, can somebody help me? Hopefully somebody will, because we have like 8,000 users a month, and some will definitely have time and skills to help you.
Thank you. I'll wait for some more questions. Um, but then, yes, again, so would you like to share like one example project or maybe the project that you worked on so people get an idea of what, like we spoke about neuroscience and all of that, but just to get a rough idea of what kind of projects there are.
Yes,
Uh, so Malin, do you want to answer that, or should I talk in brief
I
about
give
the
an
project that I
introduction and
had?
then we can continue with the specific for your project. So Arnav did this project with OpenWorm, which is a worldwide collaboration of neuroscientists and definite people with compatible skills for this project, and they try to build a model of the worm, complete model of the worm with all the cells, all the signaling between the cells, how the body moves, what the motivation is for it to move, and so on. So it's unique in its kind. Actually, I haven't seen anything that big be so successful for such a long time, and there are many branch of this project now. There is a whole different section called Devil Worm, which is just with the development of the C. elegans worm that is modeled. And I'm not sure how many hundred papers they've published, but it's a lot. If you go search for open worm on PubMed, you will find a lot. And Arnab, you did a specific thing in open worm.
Yeah. Do you want me to talk about it?
Hmm?
Yeah. So
Sure.
okay. So essentially, as Malin mentioned, so open worm, OpenWorm, because sometimes people get confused with open world. No, it's open worm, worm, that wriggly little thing which is there. So you guys might have seen or heard of the movie The Matrix, right? The movie in which they are in a simulation. So in a similar sort of way, open worm, the one line definition of what open worm is trying to do is that it's trying to create a worm within a simulation, so a virtual organism basically, an organism that can move, that can eat, that can grow, and that can also interact with its surroundings. And that organization I'm sorry, that organism should not know that it's not a living organism. So essentially you are trying to code an entire living organism in a virtual box, in a virtual environment. So why a worm, right? And why specifically this worm, which is known as um, the roundworm? It's because in the world of neuroscience, there is something called a neuroconnectome. It's basically a 3D mapping of all the nerve cells that you have in your body. And as of today, the roundworm, or the worm which has the scientific name of C. elegans, I'll actually post it. I don't see. Just a second. Yeah. C. elegans is basically, it's the roundworm, and it is the first, and if I'm not wrong, as of 2018, it was the only living organism whose entire neuroconnectome was known to scientists. So basically, scientists know how many nerve cells this organism has, and also importantly, scientists know in what order they are connected in the three-dimensional space, basically. So that is why they started building this virtual worm. Now coming to my project, what was my role in the project was that like I mentioned, uh, this this virtual worm which is there, it needs to move, it needs to eat food, it needs to grow, and it also needs to surround I'm sorry, interact with its surroundings, uh, proper, like a simulator, like just like in the movie The Matrix, the humans shouldn't know that they are in a simulation. So something similar. uh, but there were certain parts of this project which were already completed. So the movement part was completed, the interacting with its environment part was completed, but we were specifically working on how to help the worm grow from a single cell to the adult worm, basically. So in order to do that, what I had to do was I had to read through large data sets. I had to read through large data sets of embryogenesis of the worm. So data sets which had columns like cell name and the timeline, basically, that let's say today if a worm is born, then how much time it will take to become an adult, and over time how many cells it will have, and over time how the nerve cells will grow and then split into two, and then those two will split into four, and how the final adult nervous system will be formed. So I basically had to read through and analyze many simple Excel and comma separated value sheets, and then I
Mhm.
had to build out a code, basically an XML parser in Python, which would read all of this data, try to make
Mhm.
sense of the data, and then try to convert these Excel files into GML files. GML files, again, new term, fancy term, you might probably be hearing for the first time. But again, like I mentioned, this is the point of open source. So new things, when you hear, don't feel that it is something very complicated. It's just another simple thing. If you if you just Google it, you'll know. So GML is basically graphical XML files. So
Mhm.
you might have heard that there are different ways of storing data. Like people either store data in Excel files or XML files, or other formats, right? Or text files, .txt basically. So
Right.
GML files are a specific way of storing data, which can be read by certain applications like GraphViz and Gephi. Again, I'll put the names down. So GraphViz and it's GraphViz, not GraphViz. Yeah, so Gephi and GraphViz are basically open source tools that take data in GML format, and then they churn out graphs, basically interactive, colorful graphs with nodes and the connections between the nodes and the different weights. So essentially, my project, in a simple way, to understand, was that build a Python code and a Bash script to automate the entire thing. That you will give input as I'm sorry, Excel files of embryogenesis and neuroscience data, and as output you will get those interactive graphs that people can play with on the terminal in Ubuntu. And
Mhm.
although the main project was in Python, I also had to build a batch script, a bat file, to automate the entire thing basically. So
Right.
you will notice that the individual components are technically not rocket science. It's just building a Python code, building a bat file, and playing around with data, changing the format of the data. But
Mhm.
there was some element of neuroscience to it. So of course, initially I felt that maybe I won't be able to understand it, but my mentors were there to help me. So
Mhm.
whatever neuroscience related stuff I had to learn specific to the project, my mentors were there to help me. So most of the projects will be some, like, all projects are different. Some projects are similar to my project, building a Python code. Some projects
Mhm.
are building a JavaScript interface, front end, something. But at the end of the day, the concept is same, that you will have something related to neuroscience. You will have to probably learn a little bit about neuroscience, whatever is
Mhm.
specific to the project, and
Right.
then the technical part you will take care of. You will code, and that's it. And then you have a final product, I guess.
Thank you. So, question for your project. You mentioned you're looking at worms, and somebody asked, wouldn't an amoeba be easier?
Yeah, so I mean, amoeba and bacteria, all of that would be easier, but the thing is that most of the times, amoeba, bacteria, these are organisms which are too small, and the thing is
Mhm.
that in order to understand the human nervous system better, you have to
Mhm.
start at least at a certain level where there is an organism with a well-formed nervous system, like an amoeba or
Oh,
a bacteria. They are very small organisms, and in some cases also unicellular, like just one
right.
cell. But what we want is an organism that at least has a well-formed nervous system. So in order to do that, you will have to
Mhm.
go a few steps above a bacteria or an amoeba, because a bacteria or an amoeba is too small to analyze.
Thank you. Another question we have is knowing JavaScript enough to start contributing?
I would say it depends a lot on the project. Some projects need JavaScript for sure, but some others might also need some Python or some special skills in visualization or some such. So if you know just JavaScript and nothing but JavaScript, you might not be a good fit. But if you know JavaScript and a little bit of something else, it might be much easier.
Mm. Another question for you, Arnab. What inspired you to contribute to INCF?
So I think I was a bit confused between a few organizations, but at the end of the day, what really drew me towards INCF was the fact that this was one of those organizations which has a very which acts in a very special intersection between
Right.
open science and open source. So
Mm-hmm.
Google Summer of Code is about open source software, right? And
Mm-hmm.
the mission that INCF and the sub organizations of INCF have is that they are all operating in the space of open science, like
Mm-hmm.
making science accessible and helping universities and governments across the world to agree on a common set of standards, which, as Malin shared in one of the earlier slides, there's something called the FAIR neuroscience, like
Mm-hmm.
FAIR. It stands for, there are four words I actually forgot. I'm sorry, Malin.
Accessible, interoperable, reusable.
Yes, yes. So I mean, what was really exciting about INCF is that it was trying to solve a real world problem, and a problem that will actually have very far reaching repercussions, because as we are progressing in, almost all fields, be it medical field or neuroscience or technology and coding, but we don't want to end up in a world where the
Mm-hmm.
progress of science is hindered because different governments or different universities or different researchers do not agree on a common set of standards. I mean, think
Mm-hmm.
about it. So when we look at front end development, when we think about HTML is, like they say, right, it's the basic unit of, displaying data in a certain way, right? And on
Right.
top of that, JavaScript, React.js, Node.js, these are all, let's say, or Django, these are all new frameworks. You can build fancy and sophisticated websites with this. But the 101 of web development, the basics, it's HTML. And think about it, if every country had a different standard of displaying data on the web browser, then today we probably wouldn't have progressed as much as we have. So in a similar sort of way, in science as well, we are trying to ensure that the data sets and the data formats in the world of neuroscience are interoperable and reusable, so that the progress of science shouldn't be hindered because 10 years or 20 years later it happens that different countries are completely working on different data standards. We
Mm-hmm.
want the future of science to be such that the work of the researchers becomes easier, not more difficult, because of admin work, like changing data formats or something. So this
Right.
was such an exciting mission that when I read more about INCF, and I realized that
Mm-hmm.
at least at the time it seemed to be a no brainer for me to try and contribute to INCF. So that is why I contributed to INCF.
Thanks for sharing that. Um, Another question: is there any tutorial for contributing to INCF?
There is not one tutorial since we have so many projects, but many of these projects have their own tutorials. I would say
Mm-hmm.
just first looking in the GitHub repos, they might have them there. Otherwise, you search for them on our training space because we have a lot of demos there. And also Googling tutorial plus the name of the project might work.
Right. Thank you. One more question. Since INCF has been participating for so many years, what are some of the changes that you have seen in the program over the years, and what do you look in the students when selecting them? Has that also changed as well?
I would say that the program has actually been amazingly stable over the last decade or so. It has had approximately the same structure and the same time points along the line, the same checkpoints, and the same administration. And
Mm-hmm.
so that it hasn't changed much until this year because what they made is that they shortened the projects quite a lot, and they also lowered the thresholds to entry. So now you can come from lots more different places than just a data science major, and that also means that we get a bigger range
Right.
of students who have other experiences than just pure data science, which I think is a good thing, but it also means that we will need to support students in new ways. So especially this year, we are going to try to very much listen to students and say what they need help with. so that we know better going forward how to do this.
Thank you. So the next question is, what would you suggest to someone who's looking forward to contributing to INCF in the long term, even outside of GSoC?
I would say read up a little bit on scientific standards and what they mean to science. Basically, it means that you have stuff that is reusable and interoperable and so on. And there will definitely be a lot of papers on the impact of standards in general. If you want a specific example, I suggest to check out the BIDS standard, which is a way to structure your very complex neuroimaging data sets in as a specific folder structure. That might sound simple, but it enables a lot of things to work that didn't work before.
Thank you. So thank you so much for all of your amazing explanations. We also got a lot of amazing feedback over here. You can see some of these. Love the monologue. Great, motivating. So thank you so much. I'm sure the audience had a lot to learn and would definitely be looking forward to contributing or at least knowing more about INCF and neuroscience in general. I'll wait a couple seconds for any last questions. But other than that, it was great talking to y'all and hosting y'all. Thank you so much.
Thanks for inviting us.
No problem.
Thanks for having us.
Okay, so okay, we have one more question.
How an individual membership? Yes, you get access to our community. You get access to our resources. I mean, some of this you can get for free. Neurostars doesn't cost anything, for instance. But you can also be influence things, nominate people to committees, participate yourself in groups, and so on. So you get the network, I would say, and you get even more access to it if you are a member. But you are welcome to our community without paying anything, also.
Thank you. Okay, so I guess we can end the session. Thank you and bye, everyone.
Bye.